Hello everyone, I am Sajja Eswara Sai Raghava. I am from Vijayawada, Andhra Pradesh. I am currently studying in IIT Kanpur doing CSC. Today I will discuss about inverse trigonometric functions. We have 6 inverse trigonometric functions. So I will briefly tell about the properties of the functions. First we talk about sine inverse x. So this function sine inverse of x has a domain of -1 to 1. So whatever the values of x you are taking, you should take from the set -1 to 1. And the range of this function is we have we will take the range of this function as -pi/2 to pi/2. This is for our convenience and we'll call it as the principal values of the range. So whatever the value of x we have taken in our domain, we'll get these values -pi/2 to pi/2. So we have 5 more functions like this, like we have cosecant inverse x. This have the range, this has the domain as all the real values except -1 to 1. So excluding the -1 to 1, we can have the any value in the real number system. And the range of this cosecant inverse x will be -pi/2 to pi/2 excluding 0. Then next we'll talk about cos inverse x and secant inverse x. We look at the function cos inverse of x now. So as sine inverse of x, cos inverse of x has the same domain as sine inverse x. But here we will get some difference in the range of the function. So for the sine inverse x, we have the range of the function from -pi/2 to pi/2. But for the cos inverse of x, we'll have the range as 0 to pi. We'll call this as the principal value of range for the function cos inverse x. And so, and for the function secant inverse of x, the range, the domain will be r minus r excluding -1 to 1, since secant inverse x cannot take the values, secant of x cannot take the values from -1 to 1. We exclude it from the domain and the range will be 0 to pi excluding the value pi/2. And next function is tan inverse of x. The tan inverse of x has the domain R, so we can take any real value, and it has the range from -pi/2 to pi/2 by excluding the values -pi/2 and pi/2. So these are closed brackets. The previous all are open brackets. That means including the values on the extreme side, but these are closed brackets, so we cannot take the value of -pi/2 or pi/2. And similarly, cot inverse of x also has the domain of R, which implies we can take any real value, and it has the range 0 to pi. So these are very important for doing any problem. We have to have the idea about the range and domain of the function which we are using. Now we'll move to the exercise. We'll do the exercise 2.1 first. So the first these are all, the first problems are of the same type, and these are like find the principal values of the following. So we have to find the principal value of the given value. So first, sine inverse of -half. -half is in the domain of the function. So if you see, we can, for sine there is a property of sin x is equal to, so for the sin x we have a property like sin x is equal to minus of sin minus x. We call these functions as odd functions. So we know sine of -pi/6 is equal to -half. So sine inverse of -half will be -pi/6. So So the first problem answer will be minus pi by 3. Coming to the second part, second question, we want to find the value of cos inverse of 3 by 2. So as you may have remembered, the value of cos of pi by 6 is equal to root 3 by 2. So the value of cos inverse root 3 by 2 will be pi by 6. So the next problem, the third problem, we have to find the value of cosecant inverse 2. I, if you remember, the value of cosecant 5 by 6 is equal to 2. So the value of cosecant inverse of 2 will be 5 by 6. These are just memory based questions. The first up to the 10th problem, if you remember the values of the basic angles, like we know that 30, 45, 60, 90, 0 are the important angles. So we have to remember all the values of sine of the value, cos of the value, cosecant of the value. So by remembering the values of the angles of functions of different angles, we can solve the problems from 1 to 10. All are simple value. We just the answers will be the value of the following. So next we'll move to the next type of problems. In the 11th question, we have to find the value of tan inverse of 1 plus cos inverse of minus half plus sin inverse minus half. Okay, we will substitute the values here. Okay, we substitute the values of the following. So tan inverse of 1. So basically tan inverse of 1 will be pi by 4 plus cos inverse of minus half. Cos inverse of minus half will be 2 pi by 3. Sin inverse of minus half. This will be minus pi by 6. So by adding these three values, we will get our answer. So the 12th. So we move to the next question. The 12th question, cos inverse of half. So the value of cos inverse of half is pi by 3 plus 2 into sin inverse half. Okay. 2 into sin inverse half value is pi by 6. So by adding this, we will get that value 2 pi by 3, which is our required answer. So we go to the next question, the 13th question. The 13th question says if sin inverse of x is equal to y, we have to find the range of the value function sin inverse x. We know that the range of the function sin inverse x is minus pi by 2 to pi by 2 with both minus pi by 2 and pi by 2 included in the range. So our required answer will be option B. And we move to the final question of this assignment. So the 14th question says we have to find the value of tan inverse of root 3 minus secant inverse of minus 2. So the value of tan inverse of pi by 3, sorry, tan inverse of root 3 will be pi by 3 minus, you have to find the value of secant inverse of minus half. So, sorry, secant inverse of minus 2. So we know the value of cos 2 pi by 3 is equal to minus half. So from that we can get the value of the secant inverse of minus 2. So this will be 2 pi by 3 and our answer will be minus pi by 3, which is again option B. So the first exercise is mostly based on memorization of the values of the most basic angles. Now we move to the next exercise. Here it basically, this exercise deals with the relations between the sine and cos and also sine 2x bit and the relation between sine 2x and sine x. So you have to remember we have to remember the formulas of some basic relation between the sine and cos for this exercise. So we do all the questions in this exercise. So the first question says prove the following. 3 sine inverse x is equal to sine inverse of 3x minus 4x cube. Okay, and it is the the domain of x is also given. So for this type of questions, we first substitute x, and we by for proving the following statement, first we simplify the value of right hand side and simplify the value of left hand side, and at the end we will show that both the right hand side and left hand side are same. So we do the proof questions by the similar approach. So we generally simplify the value of the right hand side and simplify the value of left hand side. So in this problem, we have to do the following: 3 sine inverse of x is equal to sine inverse 3x minus 4x cube. Since we know the domain of the value of x, we can substitute x is equal to sine theta for some theta value, as the value of x is in the range of sine theta. So if we substitute this, the left hand side will be simplified as 3 theta, since sine inverse of sine theta is equal to theta. And the right hand side we will simplify. This will become sine inverse of 3 sine theta minus 4 sine cube theta. And this is equal to the value of sine 3 theta. If you remember the formula of sine theta, the value of sine theta is equal to 3 sine theta minus 4 sine cube theta. So this will be sine inverse of sine 3 theta. So here, if you look at the domain of the value theta, since x belongs to minus half to half, the value of theta belongs to minus pi by 6 to pi by 6. That implies the value of 3 theta will be in the range of minus pi by 2 to pi by 2. And we know that sine inverse of sine alpha, their alpha belongs to minus pi by 2 to pi by 2, is simply alpha. So this will get as 3 theta. So we get the right hand side is equal to left hand side, hence proof. So the next part of the question, which says 3 cos inverse of x is equal to cos inverse of 4x2 minus 3x, which is also almost same as the present question. We just have to substitute the value of x with cos theta, and by substituting again, if you simplify the right hand side and left hand side, we'll get the left hand side as 3 theta and also the right hand side as 3 theta. We can show that both the right hand side and left hand side are same. So by equating, we can say that the following statement is correct. So we move to the next question. So we have to simplify the given expressions from fifth problem to seventh problem. We have to simplify the given functions, and we have to write in simpler forms. So first we have to simplify this tan inverse root of 1 plus 1 plus x square minus 1 by x. So we should think of which one of the function is suitable. So if we substitute x is equal to tan theta, this whole term will be, we can simplify easily. So let's substitute x is equal to tan theta. If we substitute x is equal to tan theta, we will get the term inside the root as 1 plus tan square theta, which is equal to secant square theta. So this, the square and root will be cancelled, and we will get this as tan inverse of secant theta minus 1 divided by tan theta. And if we multiply both sides with cos theta and cos theta, we will get this term as tan inverse of 1 minus cos theta by sin theta. So we have to simplify this. So here we can write sin theta and cos theta as in terms of the sin theta by 2 and cos theta by 2. If you remember, sin theta is equal to 2 sin theta by 2 into cos theta by 2. And also cos theta is equal to 1 minus 2 sin square theta by 2, which is also equal to 2 cos square theta by 2 minus 1. So here, since it is 1 minus cos theta, we will write in terms of sin theta by 2. So we will, if we simplify this part, we will get this as equivalent to 2 sin square theta by 2 divided by 2 sin theta by 2 into cos theta by 2. So if we cancel the common terms, we will get this as equal to tan theta by 2. So our equation will be as tan inverse of tan theta by 2. So this will be equal to theta by 2. So since we have assumed that x is equal to tan theta, this will be equal to tan inverse of x by 2. So this is the simplest form we can get. So we should have the knowledge about all conversions between sin, cos, tan, cot, and also we should have the idea about the multiples and submultiples of this values of the functions of. So we move to the next problem, which is tan inverse of root of 1 minus cos x by 1 plus cos x. So first we will simplify the inside term, which is root of 1 minus cos x by 1 plus cos x. So the term we should simplify is of the form like this: 1 minus cos x divided by 1 plus cos x. So we write cos x in terms of the cos x by 2, and in the denominator also we will write in terms of x by 2 angle. So if we remember, cos x is equal to 1 minus sin square x by 2, which is also equal to 2 cos square x by 2 minus 1. So the numerator we will, since we want to remove the term 1, so there is a minus in front of cos x. So we will write this in terms of sin square x by 2. So we'll get the numerator as 2 sin square x by 2, and we'll get the denominator as 2 cos square x by 2. So simplifying this term, we will get this as tan x by 2. So the simplified form will be tan inverse of tan x by 2. So we know the value of tan inverse of tan x by 2 is equal to x by 2. This is equal to the x by 2. So the simplified form will be x by 2 in this case. So we'll move to the next question, which is tan inverse of cos x minus tan x by cos x plus tan x. So first we simplify the inside term, which is cos x minus tan x divided by cos x plus tan x. Then we will substitute the term here. We have the term cos x minus sin x divided by cos x plus sin x. The denominator is plus. So since there is a tan inverse term here, it is better to convert into tan. So we divided by cos x and cos x in both numerator and denominator. Then we'll get this as 1 minus tan x divided by 1 plus tan x. So you can write 1 as tan pi by 4. So this will be same as tan pi by 4 minus tan x divided by 1 plus tan pi by 4 into tan x. This is same as tan of pi by 4 minus x. Since this is, so if you remember that the formula of tan A minus B is equal to tan A minus tan B divided by 1 plus tan A tan B. So this is also similar form for the formula tan A minus B. So we will write this as tan pi by 4 minus x. Since we have tan inverse in the front and the value of x is between minus pi by 4 to 3 pi by 4. So if you substitute, we will get the value of pi by 4 minus x. It will be in the range minus pi by 2 to pi by 2. So since it is in the acceptable range of tan inverse of x, we can simply write tan inverse of tan pi by 4 minus x as pi by 4 minus x. So this is the simplified formula for the fifth question. So we move to the next question. Tan inverse of x by root of a square minus x, and it is also given that the mod of value x is less than. So if it is given that mod of x less than a and the denominator is like a square minus x square, we will substitute the value of x is equal to a sine theta in this case, since it will also satisfy the condition of mod x less than a. So we will substitute the value of x is equal to a sine theta. After substituting the value of a sine theta, we will get this one, a sine theta divided by root of a square minus a square sine square theta. So if you take this out, a out, we will get 1 minus cos square, sorry, 1 minus sine square theta. And we know that 1 minus sine square theta is equal to cos square theta. And square and root will be cancelled and a will be cancelled. We will get this as tan theta. Tan inverse of tan theta will be theta. So the simplified version will be theta. And our assumption is that x is equal to a sine theta. That implies theta will be sine inverse of x by a. So the simplified form will be sine inverse of x by a. So this is the required answer for the sixth part. So we move to the next question. So in this question, we have to find the value of tan inverse of 3a square x minus x cube by a cube minus 3ax square. And it is also given that minus a by root 3 less than x less than a by root 3. So we need to first substitute x with some suitable terms which will simplify the given expression. So first, if we look at the given term, it is of the degree 3, since the degree of a square x and x cube and a cube and 3x will all are degree 3. So for our convenience, we will just convert them into all degree 1. So first we we divide both the numerator and denominator with a cube. So we will get, after dividing the numerator and denominator with a cube, we will get the numerator as 3x by a minus x cube by a cube divided by 1 minus 3 x by x square by a square. So here, if we substitute x by a is equal to tan theta, we will get this as simplified version of 3 tan theta minus tan cube theta divided by 1 minus 3 into tan square theta. This is the formula for tan 3 theta. So this is simplified to tan 3 theta. And since there is a tan inverse for this expression, we will get our required value as tan inverse of 3 theta. And the given, it is also given that minus a by 3 to root 3 is less than x divided less than a by root 3. If we divide it with a, since a greater than 0, we'll get minus 1 by root 3 less than x by a, which is less than 1 by root 3. And so the value of minus 1 by root 3 is minus pi by 6, and the value of tan inverse of pi 1 by root 3 is pi by 6. So since 3 into minus pi by 6 is equal to minus pi by 2. So these are in the acceptable range in the domain of, in the range of the value function tan inverse of x. So this will be simply equal to 3 theta, which is also equal to 3 tan inverse of x by n. So this is the simplified value of the seventh question. So next for the next two questions, we have to find the value of the expression. So we see the eighth question. The eighth question is a simply substitution question. So here we can substitute the value of sine inverse half. The value of sine inverse half is pi by 6, and 2 into pi by 6 will be pi by 3. So the value of cos pi by 3 is equal to half. 2 into half will be 1, and tan inverse of 1 will be pi by 4. So eighth question is a substitution question. We will get the answer as pi by 4. So we will go to the next question. So here also we have to find the value of tan of half into sine inverse of 2x by 1 plus x square plus cos inverse of 1 minus y square by 1 plus y square. It is given that x is less than 1 and y is greater than 1. So here we have, it is convenient to convert this into some sort of tan theta. And so it is better to convert this into some tan something, since we know the value of 1 minus tan square theta and 1 plus tan square theta. So first we substitute x is equal to tan alpha and y is equal to tan beta. So if we substitute the values in the inside, so after substituting we will get this as 2 tan x divided by 1 plus tan square x, and the right term will be 1 minus tan square beta by 1 plus tan square beta. Okay, so we'll multiply both the denominator and numerator with cos. Sorry. Uh, okay, so we'll multiply both the numerator and denominator with cos square theta. So the numerator will be 2 into sine theta, sine alpha by cos alpha into cos square alpha. So the numerator will be 2 sine theta, so sine alpha cos alpha divided by cos square alpha plus sine square alpha. We know that the value of cos square alpha plus sine square alpha is equal to 1, and 2 sine alpha cos alpha can be written as sine 2 theta. Since we have the sine inverse, this will be equal to 2 alpha. Here also, if we multiply and divide it by cos square beta, the denominator will be again 1, as we saw before, and the numerator will be cos square alpha, sorry, cos square beta minus sine square beta. This is equal to cos 2 beta. Since we have the cos inverse here, this will be equal to 2 beta. So we have to find the value of tan half into 2 alpha plus 2 beta. If we cancel the value 2, it will be tan of alpha plus beta. So tan alpha plus beta is equal to tan alpha plus tan beta divided by 1 minus tan alpha into tan beta. If we see our assumptions are x is equal to tan alpha and y is equal to tan beta. So if we substitute them back, we will get this as x plus y by 1 minus x square. So this is the value of the ninth question. So we'll move to the next question. So the next questions we have to find the values of each expression. Okay. So the 10th question, sine inverse of sine 2 pi by 3. So the value of sine 2 pi by 3, we know that the value of sine 2 pi by 3 is equal to root 3 by 2. So the value of sine inverse of root 3 by 2 can be found. It is pi by 3. So the answer of 10th question is pi by 3. So similarly, we will do the 11th question. So we have to find the value of tan inverse of tan 3 pi by 4. So the value of tan 3 pi by 4 is minus 1. So the value of tan inverse of minus 1 will be minus pi by 4. So, okay, let's see that one question. That one question, it says tan of sine inverse of 3 by 5 plus cot inverse of 3 by 5. Okay. So first we'll convert this sine inverse of 3 by 5 and cot inverse of 3 by 2 into tan. So so by expanding this tan A plus B, we'll get simpler terms. So we know sine. So we don't know the value of theta. We know that sine, let us think sine theta is equal to 3 by 5. So we can find cos theta, which is equal to root of 1 minus sine squared theta. So 1 minus 9 by 25, which is 16 by 25. Since we have root, it will be 4 by 5. So cos alpha will be 4 by 5. So tan alpha will be 3 by 4. We can say alpha is equal to sine inverse of 3 by 5, which is equal to tan inverse of 3 by 4. Also, we know that tan inverse of x is equal to cot inverse of minus x. Sorry, cot inverse of 1 by x. So we'll get this as tan of tan inverse of 3 by 4 plus tan inverse of 2 by 3. So by expanding this, we can, as we know the formula of tan A plus B is equal to tan A plus tan B divided by 1 minus tan A tan B. Tan A will be tan of tan inverse of 3 by 4, which will be 3 by 4 plus tan B is equal to tan of tan inverse of 2 by 3, which is equal to 2 by 3 divided by 1 minus 3 by 4 into 2 by 3. So this will be cancelled. It will be 2 into 9 plus 8, 17, 17 by 6. So we'll get this as equal to 17 by 6. So we move to the next question. So we have to find the value of cos inverse of cos 7 pi by 6. So the value of cos 7 pi by 6. First we have to find the value of cos 7 pi by 6. So the value of cos 7 pi by 6 is equal to minus of root 3 by 2. We have to find the value of cos inverse of minus of root 3 by 2. So this is equal to 5 pi by 6. Option B. So the next question we have to find sine of pi by 3 minus sine inverse of minus of. Okay. First we substitute the value of sine inverse of minus of. So the value of sine inverse of minus half will be minus pi by 6. So pi by 3 minus half minus pi by 6. So this will be plus and it will be equal to pi by 2. So we will get sine pi by 2 is equal to 1. So the 15th question. Tan inverse of root 3 minus cot inverse of minus 3. So the value of tan inverse of root 3 is pi by 3 minus of cot inverse of minus root 3. This is 2 pi by 3. It, sorry, it is not 2 pi by 3. It will be 5 pi by 6. So pi by 3 minus 5 pi by 6 is equal to 2 pi by 6 minus 5 pi by 6 is equal to minus 3 pi by 6 is equal to minus pi by 2. So option B. So we have completed the exercise 2.2. We move to the miscellaneous exercise on chapter 2. Okay, the first question. We have to find the value of cos inverse of cos 13 pi by 6. So we know that cos of pi is equal to cos of 2 pi plus pi. So by using this fact, we can say cos 13 pi by 6 is equal to cos pi by 6. So we know that cos inverse of cos pi by 6 is equal to pi by 6. So the answer of first question is pi by 6. So similarly, we can also say that tan theta is equal to tan pi plus theta. So using this fact, we can say that tan 7 pi by 6 is equal to tan of pi plus pi by 6 is equal to tan pi by 6. So we the value will be tan inverse of tan pi by 6, which is equal to 6. Next, we'll go down. We have to prove that 2 sin inverse of 3 by 5 is equal to tan inverse of 24 by 7. So I think it will be better if we convert the sin inverse 3 by 5 into some tan. I think we have done this above. Okay. If we know, so if you think that sin alpha is equal to 3 by 5, we'll get cos alpha by using the formula root of 1 minus sin square alpha. So we'll get the value of cos alpha as 4 by 5. So dividing sin alpha and cos alpha, we'll get the value of tan alpha. So we can rewrite the statement as 2 tan inverse 3 by 4 is equal to tan inverse 24 by 7. So we also know the formula. So we can say we know that 2 tan inverse of x is equal to tan inverse of 2x by 1 minus x square. So this, if we simplify the left hand side, we will get tan inverse of 2 into 3 by 4 divided by 1 minus 3 by 4 whole square. That is 9 by 16. So the denominator will be 1 minus 9 by 16, which is 7 by 16. And if you send the 16 to the numerator, it will be 16 into 3 by 2, which is 24. So this will be equal to tan inverse of 24 by 7. So we got the left hand side is equal to right hand side. Hence we can say that LHS and RHS are same. Hence proved. So we move to the fourth question. So here we have to do sin inverse of 8 by 17 plus sin inverse of 3 by 5 is equal to tan inverse of 77 by 36. So here also first we convert the values of from sin inverse to tan inverse using the previous technique. So if sin alpha is equal to 8 by 17, we'll get cos alpha as root of 1 minus 8 square. 8 square is equal to 64 divided by 17 square, which is 289. So we get 289 minus 64, which is 225, which is also equal to 15 square. So we'll get cos alpha as 15 by 17. Hence we'll get tan alpha as 8 by 15. So we'll get alpha is equal to tan inverse of 15. Similarly, we will get sin inverse of 3 by 5 is equal to tan inverse of 3 by 4. So we can write this as tan inverse of 8 by 15 plus tan inverse of 3 by 4. Okay. We, after simplifying, we will get this as tan inverse of 3 by 4. And we should check that whether it will be equal to tan inverse of 77 by 36. 77 by 36. So for proving it, we first, since all are positive, as 8 by 15 and 3 by 4 and 77 by 36 are all positive, we can apply tan on both sides to prove this. So after applying, we will get tan, we will get in the form of tan A plus B. So we know the formula of tan A plus B, it will be 18 plus 15 by 8 by 4 minus 1 minus 8 by 15 into 3 by 4. This will be 24 plus 45, 45 plus 32, 77 by 60 divided by 60 minus 24, which is 36. by 60. So this is equal to 77 by 36, which is equal to the right hand side. So hence left hand side is equal to right hand side. It is proven that the value tan inverse of 8 by 15 plus tan inverse of 3 by 4 is equal to tan inverse of 77 by 36. So next we move to the fifth question. So here all are cos, cos inverse of x terms. So we can easily check this by applying cos on both sides. So we know cos a plus b is equal to cos a cos b minus sin a sin b. So first we have to find the cos inverse of 4 by 5 in terms of sin inverse of it. So we, if you suppose cos alpha is equal to 4 by 5, we will get sin alpha is equal to root of 1 minus 4 square by 5 square, which is 16 by 25. So we'll get sin alpha is equal to 3 by 5. So similarly, if you take cos alpha is equal to 12 by 13, we'll get sin beta as 5 by 13. So now we'll apply cos on both sides. So cos a plus b, which is equal to cos a cos b, which is 4 by 5 into 12 by 13 minus of sin inverse 3 by 5. So this is equal to 3 by 5 into 5 by 13. So this will be 65 in the denominator. 48 minus 15. This is equal to 33 by 65. So this is equal to right hand side, which is cos of cos inverse of 33 by 65, which is 33 by 65. So we can prove that RHS value is equal to LHS value. Hence we can say that both the terms are equal. So the sixth question is also similar. Like here, if you first convert the cos inverse of 12 by 3 into sin inverse, in just we have done, it will be equal to sin inverse of 5 by 3. So the problem will be sin inverse of 5 by 13 plus sin inverse of 3 by 5 is equal to sin inverse of something. So if we apply sin on both sides, it will be sin a plus b, which is equal to sin a into cos b plus sin b into cos a. We know the value of sin a cos a and sin b cos b. So by substituting, we can just check the whether LHS is equal to the RHS. If it is not equal, we can disprove that this expression is wrong. If it is equal, we can show that both the terms are same. So the seventh question. Here also we'll convert tan inverse and cos inverse into tan inverse, which is easy since we have been dealing with numbers 5 by 13, 12 by 13. This is easy to solve. So after converting, you will get tan inverse of x is something equal to tan inverse of a plus b. So this can be proved by applying tan on both sides. So if we after applying tan on both sides, if you get the value, so we if we apply tan on both sides, we will get if we get the same value, then it will be correct expression. And the formula of tan a plus d is equal to tan a plus tan d by 1 minus tan a tan b. So by substituting the value of tan a and tan b, if we get the both sides to be same, then we can say that the expression is true. So we move to the next question, which is 8. So in this question, we have to prove that tan inverse of root x is equal to half into cos inverse of 1 minus x by 1 plus x. So for solving root x, we first simply substitute such that the simplification becomes easy. So to simplify root x, we will just assume x is equal to tan squared theta for some theta, and we will proceed. So first our assumption is x is equal to tan squared theta. So from this, if we substitute, we will get off tan inverse of tan theta, which is equal to theta, and the right hand side will be half into cos inverse 1 minus tan 1 minus tan square theta divided by 1 plus tan square theta. So the value of 1 plus tan square theta will be secant square theta. So secant square theta, we can write secant square theta as 1 by cos square theta. So the cos square theta will go to the numerator. So the numerator will become cos square theta minus cos square theta into tan square theta. We know cos square theta into tan square theta is equal to sin square theta. So the numerator will be cos, cos square theta minus sin square theta, which is also is equal to cos 2 theta. So this term will be t. So this is simplified into theta is equal to half into cos inverse of cos 2 theta. So this will be 2 theta. So this will be half into 2 theta. So this is true. Since this is true, we can prove that our statement is correct. So the next problem, we have to show that cot inverse of root of 1 plus sin x plus root of 1 minus sin x. So okay. So we have to find a way for removing these square root terms. So I think it will be better if we multiply both the denominator and numerator with the numerator, since it will be easy to simplify. So assume 1 plus sin x as some a and 1 minus sin b as b. So this is like our, so we have to solve this. So if we multiply both the numerator and denominator with the numerator, this will become a plus b plus 2 root ab divided by a minus b. So if we substitute the value of a and b, we'll get this as, so 1 plus sin x minus 1 minus sin. So we'll get this as 2 sin x, and the numerator will be a plus b, which is equal to 2 plus 2 into root ab. A into b is equal to 1 minus sin square x, which is equal to cos square x. So the root and square will be cancelled, and this will be equal to 2 cos x. So this will be 1 plus cos x divided by sin x. So we have to find the cot inverse value of the this term 1 plus cos x divided by sin x. This we can prove it by simplifying into x by 2. Like if we write cos x in terms of x by 2 and sin x in terms of x by 2, we can simplify it. Like the numerator will become, if we write cos x in terms of cos x by 2, we know that cos x is equal to 2 cos square x by 2 minus 1. So the plus 1 and minus 1 will be cancelled. So it will be 2 cos square x by 2 divided by 2 into sin x by 2 into cos x by 2. So this will be equal to cot x by 2. So the value will be cot inverse of cot x by 2. Since we have given the x belongs to 0 to pi by 4, then x by 2 will be in the range of 0 to pi by 8. So for this range, we can say cot inverse of cot x by 2 is equal to x by 2. So this is our left hand side. Our right hand side is given as x by 2. So we can say left hand side is equal to right hand side. Hence, the given statement is proved. So we move to the next question. In that we have to prove the tan inverse of root of 1 plus x minus 1 by 6 divided by 1 plus x plus root of 1 minus x is equal to pi by 4 minus half into cos inverse x. And we have been given the domain of the x, and we have also given a hint. Put x is equal to cos 2 theta. So first we will put x is equal to cos 2 theta, and we will simplify the left hand side first, and we'll check whether it is equal to the right hand side or not. Okay, so first we substitute x is equal to cos 2 theta. So that the left side term will be 1 plus cos 2 theta minus root of 1 minus cos 2 theta divided by 1 plus cos 2 theta plus 1 minus cos 2 2. So we can say 1 plus cos 2 theta is equal to 2 cos square theta, and also 1 minus cos 2 theta is equal to 2 sin square theta. So if we write them in terms of cos theta and sin theta, it will be 2 cos square theta minus root of 2 sin square theta divided by root of 2 cos square theta plus root of 2 sin square theta. So the root 2 is common in all the terms, so we can cancel root 2 in all the terms. And also if we cancel the square and root, it will be cos theta minus sin theta divided by cos theta plus sin theta. So if you see, we have to prove that it is equal to some sort of pi by 4 minus half into cos inverse x. So if we write this in terms of tan A minus B format, we can easily solve this. So we first divide both numerator and denominator with cos theta. So this will be equal to 1 minus tan theta divided by 1 plus tan theta. And if we replace 1 with tan pi by 4, we will get this as tan pi by 4 minus tan theta divided by 1 plus tan pi by 4 into tan theta. So this is equal to tan pi by 4 minus theta. So we have substituted x is equal to cos 2 theta. It is given that x belongs to minus pi by 2 to 1. So, so we'll get the theta range between in the valid range of minus pi by 2 to pi by 2. So this tan inverse of tan pi by 4 minus theta will be equal to pi by 4 minus theta. And we have substituted x is equal to cos 2 theta. So we'll get x is equal to half into cos inverse of x. So we can substitute the value of x in this step, and we can now see that the left hand side is equal to right hand side, and it is proved that the left hand side is equal to right hand side. So we move to the next question. So okay. So in the next type of questions, we have to solve the equation. That means we are given that some two equations are same, and we have to find the values of x for which the equations will be same. So we'll do the 11th now. For the 11th question, the equation is 2 tan inverse of cos x is equal to tan inverse of 2 cosecant x. So first, okay, since it is the format of 2 tan inverse of x, you can write this tan inverse of 2x minus 1 by x square, that is tan inverse of 2 into cos x divided by 1 minus cos square x. So we know the value of 1 minus cos square x, it is equal to sin square x. So we have the equation now, 2 cos x by 1 minus sin cos square x is equal to tan inverse of 2 cosecant x. So this will be equal to 2 cos x by sin square x is equal to, so since it is of the form tan inverse of x is equal to tan inverse of y, we can show that if x is equal to y, then it can be also shown that tan inverse of x is equal to tan inverse of y. So this we can show if x equal to y, that is 2 cos x by sin square x is equal to 2 cosecant x, which is equal to 2 by sin x. So this will be equal if cos x is equal to sin x. So we can say that this is equal if tan x is equal to 1. That implies x is equal to pi by 4 is the solution of this equation. So solution. This is the solution of this equation. So we move to the next question. So the next question is tan inverse of 1 minus x by 1 plus x is equal to half of tan inverse of x. So tan inverse of 1 minus x by 1 plus x is equal to half into tan inverse of x. So for this equation, since both are of the form tan inverse and tan inverse, first we'll take x is equal to tan theta. So then the right hand side will be equal to theta by 2, and left hand side it will be equal to tan inverse of 1 minus tan theta divided by 1 plus tan theta. So this 1 minus tan theta by 1 plus tan theta can be written as tan pi by 4 minus theta. So if we simplify further, it will be equal to pi by 4 minus theta. So pi by 4 minus theta is equal to theta by 2. That implies 3 theta by 2 is equal to pi by 4. And theta is equal to pi by 6 is the solution for this. So theta is equal to pi by 6 is the solution for the 12th question. So we move to the next question. So we have to find the value of sine of tan inverse of x. So here we have been given the value of tan, and so let us assume that okay, let us assume that for some alpha we know that tan alpha is equal to 6. So to convert the tan inverse of x into sine inverse of x, we need to find the value of sine alpha. So we know the value of tan alpha. We should find the value of sine alpha. Okay. So first we can from the value of tan alpha, it is easy to find the value of secant alpha. Since secant alpha is equal to root of 1 plus tan square alpha, we can say that secant alpha is equal to root of 1 plus x square. That implies the value of cos alpha is equal to 1 by root of 1 plus x square. So we need to find the value of sin alpha. So sin alpha is equal to root of 1 minus cos square x. So this will be root of 1 minus 1 by 1 plus x square. So the numerator will be x, and this will be equal to x by root of 1 plus x square. So the value of sine, we know that alpha is equal to tan inverse of x. So the value of sine of tan inverse of x is equal to x by root of 1 plus x square, option D. So we move to the next question. The next question is sine inverse of 1 minus x minus 2 sine inverse of x is equal to pi by 2. So we have to find the value for which value of x for which this equation holds. So first we should think of some substitution which will make the problem easy. So first let me erase the previous question. So first assume that x is equal to some sine theta. Then we can say sine inverse of 1 minus x is equal to pi by 2 plus 2x, since sine inverse of sine theta is equal to. So if we apply sine on both sides, it will be 1 minus x is equal to sine pi by 2 theta, and we know sine pi by 2 plus theta is equal to cos theta. So this will be equal to cos 2 theta, and cos 2 theta is equal to 1 minus sine square, sorry, 1 minus 2 sine square theta. So since we have used that x is equal to sine theta substitution, yeah, if we substitute that, we'll get 1 minus x is equal to 1 minus 2x square. So this will be same as x is equal to 2x square. That implies x into 1 minus 2x is equal to 0. We can say x is equal to 0 and x is equal to half are two solutions. So if we substitute x is equal to 0, we'll get sine inverse of 1 minus 2 sine inverse of 0, which is equal to pi by 2. But if we substitute x is equal to half, we'll get sine inverse of half minus 2 sine inverse of half. So it will be minus, sorry, pi by 6 minus 2 into pi by 6, which is equal to minus pi by 6. So the equation is not correct if we take x is equal to half. Here, here we have used that sign. We have applied sign on both sides, but sometimes sign of sine inverse of 1 minus x may not be equal to 1 minus x. So we have to check whether our solutions are matching to the equation. So here 0 is matching the equation, but half x is equal to half is not matching the equation. So this is the end of the exercises in inverse trigonometric functions. Okay, thank you.